going to have a webinar, but I wait 1 minute to everybody can join. Hello and welcome to Mitsubishi's webinar called Smart Automation for Servo and Control Unit. Please leave your microphones muted, and then we have a short discussion and questions after this session. My name is Fredrik Stråle. I'm sitting in Sweden. I'm going to present for you simple motion and how to simulate this. I'm going to show you this Mitsubishi servo system and also the control system, the different types, and I'm going to show you GXWorks 3 with simple motion. I'm going to show you the ready-made function blocks that we made in Sweden. I'm also going to do a simulation. I'm going to show you some functions for troubleshooting and also connecting to a GOT panel. Servo. This is our servo system that Mitsubishi offer. We have two series. One a little bit more cheap and not so many functions called MRGE, and also we have a series MRG4. We can connect them in different ways. We can have it standalone, doing the work alone. We can connect it with directly with a GOT. We can control it with I/O from a PLC. Use simple motion as I'm going to show you today, and also we have a motion CPU for complicated application. Please remember that we can easily replace the older ones, the older systems with this. It's a good compatibility to MRJ2 and MRJ3. First, MRJE. It's a smaller servo unit up to 750 watt. We have one phase only. It's a little bit less pulses per rotation, 131,000. It's not little, but it's less than the other system. We can control it with analog input, with pulse input or digital input. We have a unit with fiber calling SSE net. We have also possibility to run it with CC-Link iField Basic directly from a PC. Then we have MRJ4. It's a wider range of amplifier. We have from 50 watts up to 55 kilowatts, and also if on questions we can go up to 220 kilowatts. The smaller ones are one phase, and the big ones are three phase, 400 voltage AC. The encoder is 4.1 million pulses per revolution. That's very high for high accuracy. The amplifiers are for one axis or two axis or three axis as the picture shows. And this means that you can have a compact and nice installation. Safe torque off as standard, and we have full safety for with extra module. Then we have a safe standstill and safe torque, limited torque, and so on. The MRJ4 we can connect with analog poles and digital as the other one, SSC net, Syslink I-Field Basic directed to a PLC, or Syslink I-Field 1 gigabit for IQR and so on. We have also modules for Profinet, EtherCAT, and Ethernet IP. Simple motion then that's an extra module for the PLC, and we have different ones. We have for the L series system, LD77. That's 3 units up to 16 axis. This is connected with fiber to the servo. We have the similar ones to the Q system, QD77. We have also a module for Syslink I-Field for the Q system. This is programmed by GXWorks2 then. For the FX5 EQF system, we have a module called FX540 SSC or 80 SSC. It's for 4-axis or 8-axis. We can then add up to 4 of these to one PLC. For the IQR system, we have an RD77MS with up to 16 axis, and also on that system you can add more than one module. And also a Syslink I-Field 1 gigabit system. This is up to 32 axis in one system. What can we then do with this simple motion system? I will show you a couple of typical simple motion machines. Handling robot. You can easily do a pick and place unit. X, Y, and Z axis can go synchronized so that you know where you are. You can do linear applications and also circular movement. You can do like a rotary knife cutting machine paper handling. This is standard built-in CAM modules for this application. We do a filler unit, and just this month we released a face mask function block package, so you can do face mask for the coronavirus. So if you have a machine that mechanical is like this, then you can turn the machine to a face mask production unit. This is in combination with the other cutting and also. So if you're interested, just talk to salesperson, then we can help you with this. Benefits with simple motion. You can do much of these functions with the PLC only, or just with I/O and so on. But with simple motion, it's easy to synchronize axis. You can switch on and off axis, synchronize with the different axis in directly. It's expandable. It's easy to add more axis and getting work easy and quick. You can change the functions. You can change from position mode to speed mode to torque mode in just programming. And the positioning doesn't affect have no effect on the PLC. So if you have a start with a small PLC program and then the PLC program expand and the cycle time increases, the positioning is and synchronization is still the same, because everything is working in the simple motion module. And it's cost effective. You don't need to have a lot of IOs on the PLC to control the axis. Everything is controlled by the simple motion module. So I think it's a good way to get this working. Okay, I will show you how it works in the GXWorks 3 then. Beginning, you just add an module, the module configuration, and then it's adding it as a module extension. And with our example project, you get a function block to control it. Explain a little more. At these inputs, you have a jog mode. You can choose the jog speed. You have control your torque. You can stop your motor. You can start absolute positioning, relative positioning. You can also synchronize directly from this. And the readout from this is also position, speed, torque. Your position completed, servo and ready, and you have all alarms. Both has a bit for that it is an alarm and also alarm code. You have indication for limit switches, also battery warning for you have absolute positioning. I will show you how it works. We should start the simulator then. So it's everything is included in this function block. So there are no need for anything else. For the simple motion then, I will come back to this times. You set up the system, how many axes you got. You can also choose if it's a MRJ4 or a MRJ3 or MRJE. Then you can also choose if it's an actual axis or a virtual axis. So if the system is not, if the machine is not ready-made, then you can turn the axis to virtual and then test run it anyway. I have a couple of parameters for setting up the system. Gearing, for example, there's a guide that you can choose different types of mechanical system for the help to calculate the gear, how many pulses per revolution that you want. You set up maximum speeds, maximum torque limits and so on, and also, for example, the homing. And for just to show it, if you choose some type, you have a help window below. Explain what this do then. We have also the servo parameters from here, which means that when you set up a servo, you only set up it here. And when the machine starts up, it sends all the parameters to the servo. So there's no need for servo parametration directly to the servo. So if you need to change the servo, then just tell which axis number it is, and then turn on the machine, and all the parameters are directly into the servo. And all of this is only in one file, the GeeksWorks3 file. So here is set up the system for servo. Exactly the same as on the other one. You have a help in the bottom, so it's easy to read out what you change. The system works as in position data. So with our function block, then we send a function block like row 1, do a linear movement, 2 axes, interpolate with axis 2, acceleration, position, and speed. Then you make a start of that. So if you want to do an easy machine, then you can just put all the data inside here, then only do a start command from the PLC. Then you can also set up as an offline simulation. Then you see that this is simulation of a row 1. If you do a linear movement in 2 axes, then you also have to define the second axis, and that's in this case axis 2. And on row 1 at axis 2, it's only the end position that we need to add. And therefore the relation of relation of this is from 0 to 1000. If you want to do a more complicated positioning, then I have to one example here: 2 axis linear to one position, then I do a circular movement, an arc, axis 2, then I have to also position the arc center. And I want to do a full circle, then I have to do it in 2 movements. First a half circle and then another half. And if you simulate this, it looks like this. So in this FX5 system, you can do 3-axis linear movement or 2-axis circular movement as maximum. I will show you also in this simulation. So that's pretty much everything to start a simple communication. I will also show you the synchronous parameters. It's a bit complicated as it looks, but it's not that easy, not that simple. Let's say that you have an output axis that you want to move. In this case, axis 1. We have all the parameters in axis 1 here, like this. So this is axis 1. Then you can follow the mechanical movement up to here. This is axis 2. I set in axis 2 there. That means when it's in synchronous mode, then it will follow the axis 2 directly. There's no mechanical things here, but you can add a coupling that you can couple in and out whenever you want. You can add an other axis, an adding axis. You can do a gearing, do an electrical gearing. You can add another axis. You can add couplings to that. You can add electric gearing on that. And you can also do a speed chain gear at the end. So in this way you can do, for example, a rotary knife or maybe a flying shear. That's a good example. Then so this is the axis then that you should follow up and cut with, the axis 1. So then you add axis 2 as a belt. Then you have a mark detection taking care of how much you have to speed up, and then you add this axis for hunting up the value. That's only that you have to do. If you have a rotary knife, for example, or something else mechanical that's not linear or something, then you can add a cam. I will show you how you do a cam, for example. This is a cam just made for as an example. You can do it directly here, or you can do it in Excel and import the Excel sheet to get exactly the cam that you want. So saying this is a simple motion unit, yes, it's simple to configure and set it up, but it's not simple in the way that you cannot do anything. You can do almost everything. I will come back to this and show you a little bit after we have done the simulation. To simulate a machine like this, maybe you have already tried the ordinary simulation for PLC, but we have also a system simulation that simulate also the intelligent modules. So you have to start a system simulation. I have to add a system, and I add the actual project. I also have to click the modules that I want to use. It could be several modules, but this is only one. Then I start the system simulation. So this window is now only for stopping or resetting this PLC if you want. You see now that it's an error because it's no program inside. So just close it, and the other window is this. This is showing exactly the same LEDs that are on the module. So now the simulation is on. Then I have to also connect the PC to the simulator. This is done with the connect simulation. Connect. So instead of trying to find the Ethernet port to download the system, it's download to the simulation. Then I have to write the program. And I have to also download it to the simple motion module. Do an execute. This takes a short time. I think it takes exactly the same time as if it's an physical FX file. It's resetting the simulator as showed, and we are ready to run. We have also a tool system. We can simulate a lot of things on this. You can simulate encoder input. If you want to follow something, then you can start an external axis, and you also can simulate the inputs on the actual module and also on the servo. For the servo units, if it's limit switches on the servo unit, then you have to change this to make it work. Because otherwise it's alarming for hardware limit switch or something. It's depending on how you set up the system, but you can choose it here. So if it should be a normal system, then you can see every signal here. The problem is with Skype, some issues, so you cannot see if it's hot or not. So we have to use the watch window. This is only when I do this in Skype mode. So I use the watch window instead, just to show you. I can do servo on axis 1, on, and it's on. I can see if it's do a jog, and you can see the position moving. So in just a minute or two, then you can test your program. The only thing that you cannot see is if you look at the values, then you have the position and you have the speed, but no torque, and that's because it's simulated. So if you have logic with this torque, then you have to do some programming to avoid to get the program to work. But that's the only thing that's not simulated. That's because of the mechanical. We have no mechanical, of course. So this is actually quite easy to make it work. And if you can look in the simple motion monitor. This here's a good view of what's happening in the system. You can see to the right, it's if the PLC is ready, if you have all axis on, or just in this case one axis on, and you have a busy and alarms and so on. If I have to start the positioning, how it's running. You can see also in the axis monitor that everything is moving. So that's for simulation. And for running a machine, you can jump through the program and you can test and simulate. I prefer to use the GOAT program to simulate, because then you can also see your screen and everything that you want. You can make an example project just to test, or you can use your ordinary program. Start the simulator for GT Designer, GT Works, and it's connected to the simulator. a while. That. So here is an example screen, and then you can see that servo on axis 1 is on. You can turn it off and on. We have all the axes also on this one. So I turn it on and I do some jogging. It's working. So if we, for example, turn the servo off and try to jog, then we get an alarm. We can reset it from here also. This is a good way to test the machine. For running in absolute mode or relative mode, we have to do a homing, and in this case, the home is only set by 0 at where you stand. We enter a command position and start absolute positioning. We have still an alarm. Okay, what's wrong? We have no command speed, of course. So now you can see that we have going to position, and we have position completed. Absolute position is going to one position. Relative positioning is going from where you are 1,000 points forward. So then you can do it over and over again. This is an easy way to test that you have everything functioning. We do the same on we set servo on axis 2 and also do a home on that one. So then I can show you how to do positioning. I made a screen just to show you in a graphical way that we have movement. And I also did a small example program. So to simulate the machine, okay, the machine program will work, but it's difficult to see where you are and how it works. So in this way, you can just make a good visualization what's happening. And of course, you can do a circular movement also and so on with the rotary unit. And as I show you in this offline simulation. Okay. One. Sorry. This circular unit, this circular movement, it's done by 3 function blocks, 3 position blocks. If I run it in sorry. A lot of windows open. I can do it in also like this. Now it's not the circular unit because it's the wide screen and you want to use all the screen, but still it's a circular movement. Going to 1,000. So it's quite easy to make a simulation and also make a standard a window to show the movement on the screen. To make synchronization, made another small screen. Here you can jog axis 1, axis 2. And if you want to sync it, just press sync and then you run axis 1 and the axis 2 will follow. And if I want to do some gantry axis, for example, then you have to move the axis together before and then sync it. So I have done a small program for gantry. Like this, and then you have a parallel movement. This also works in absolute and relative positioning, of course. So for simulation, it's quite easy. For the simple motion at all, it's very easy. And this program example, for example, we have if you should look for something that goes wrong, we said servo off, try to jog, get an alarm, we look in the list, start is not possible, and then you get the alarm code and exactly the right as in the book. We read out the alarm code. Do a alarm here also. If we look at the axis monitor, you can see the alarm and you can press it and you get the same alarm and also how you can fix it. That's very easy to work with. So our function block then, we short look at that. We have an array of struct, so you can use it in your own program. It's connected to variable bits and registers just to get connected to the GOT. But if you want to have something else, then not included in the system, then there you can use our module labels. That's a standard function in G3. You can find whatever you want and just draw it into the machine, to the PLC. And here's two examples of what I've done. I put in command position and command speed. So if you want to use it in somewhere, then it's a good text message. The array is axis number and then You can see also that's module buffer memory for that. And this buffer memory is which I use in the simulator. If you want to show it on screen, then you can add an object, put in U1 for unit 1 motion module, and then G2400, and that's the command position. So there's no need for PLC programming just to show a specified buffer memory. The GOT is taking the information directly from the simple motion. So no need for PLC programming just to show. That's exactly how I did in these pictures. Took a slider and just put in position for axis 2 and for axis 1. So how do you find this buffer memory addresses and so on? In the simple motion module settings, press help and buffer memory list. You get a Excel sheet with all information. You have a parameters, monitor, control, positioning, sync parameter, and also at the end, I think you have also servo parameter. So you can change servo parameters directly from the PLC. I think it's quite good system. Everything is controlled by the PLC if you want, or the motion unit. So this is how it's connected. To see what's happening in the servo unit, and you can, of course, this was for simulation. It's not possible to see. You can also see happening in the servo. Oh, that was the same. So this is for not seen in simulator, but it's for the all axis in real mode. Sorry. For servo monitor, you can also choose show, for example, drive recorder. Then you come directly into the system. This is exactly the same as MR configurator. So this is also for real diagnosis. But anyway, start only with GX3 and everything is included. So that's pretty much everything that you have to do. So some of our customers buy the servo units first and then start the program. It's actually possible to program the machine and then buy the units. Or if you buy the units, you can start this at the same time to program. You have only a couple of days of delivery time, but anyway, you can prepare the machine exactly as you want. So that's all I'm going to show today. Summary then. We have ready-made function blocks. We have a quick start guide. I can show it. When you download the example program, you get a quick start guide, of course. How you connect the drive, how you set up everything, how we install it, every explanation of all functions. That's what I showed today. You have a servo, motion, PLC, everything in the same project. You don't need to have different files in a project to ensure that everything is up to date. It's easy to set up. We can get a machine running in a couple of minutes. And as before, everything is reachable from the same software. Okay. Anyone has any questions? It's good you can type it as a message or turn off on your microphone and ask. There's something I missed.